This is a good basic question on indices, and even though the parts here A, B and C are relatively straightforward, very few students actually get them all right. So if we look at this question and we start off here with something relatively easy, 6 to the power of minus 2. Of course, we're looking at our rules here on the right hand side, and these rules are on page 21 of your table book. A to the power of minus p is 1 over a to the power of plus p. So I can say 6 to the power of minus 2 is 1 over 6 to the power of plus 2, which is of course 1 over 36. Then if I have a to the power of 1 over q, it's the q root of a. Okay, so 81 to the power of a half would be the second root of 81, or obviously more typically as we call it, the square root of 81, which would be 9. If I have to express 2 to the power of 24 in scientific notation or standard form, well, I then have to get it to 3 significant figures. But if I start off with 2 to the power of 24, and that's going to be equal to 16777,216. If I think about, well, the decimal point would be here at this place. If I wanted in scientific notation where there is one digit to the left of the decimal, it'd be 1, 2, 3, 4, 5, 6, 7 jumps to make that happen. So this number could be written as 1.6777,216 by 10 to the power of 7. I then want to correct the 3 significant figures. So what do? I look at the fourth significant figure, and remember the fourth significant figure is the 7. Okay, and why is that? Because the number to the left, the 1 here, is also significant, so that makes it different from the decimal places. Because my fourth significant figure is a 7, that's what I would call the decider. That means I'm going to round up the third significant figure, so I'm going to round that other 7 up to an 8, and my answer then is going to be 1.68 by 10 to the power of 7. 1.68 by 10 to the power of 7. So that would be 16,800,000 if we wrote it out fully. So that press shift mode science 3 on the Casio calculator, that's the older version of the Casio. Show that a times square root of a all to the power of 3 divided by a to the power of 4 simplifies to the square root of a. So there are a few different ways to do it. You could write it all out, a root 3, a times root a by a times root a by a times root a. You could do that. Or, and if you were doing it that way, you'd simplify it down bit by bit, but I would be inclined to use my rules of indices. And again, I'd start off here. I'm going to use my first rule of indices. When I'm multiplying the same base, I add the powers. I remember, of course, that the square root of a is a to the power of a half. So we have a to the power of 1 times a to the power of a half. Multiplying the same base, I add the powers. I get a to the power of 3 over 2. I'm now going to use my third law of indices, which says when you got one power raised to another power, you multiply those powers together. So you get a to the power of 9 over 2 divided by a to the power of 4. When I'm going to use law 2 here now. When I'm dividing the same base, I subtract the powers, so I get a to the power of 9 over 2 minus 4. I get a to the power of a half. A to the power of half, of course, is root a, so I have completed the question. So, you know, there's a little bit of work in it, but it is just using steps 1, 2 and 3, and of course remembering that a to the power of a half is the square root of a. And the last part here, you know, some students would struggle a bit with this, but if you've seen a couple of them, it's relatively straightforward. 49 to the power of x is equal to 7 times 2 to the power of x, or 7 to the power of 2 plus x. What do we do? The 49 is the key. The 49 is the key because we know 49 is 7 squared. So 49 is 7 to the power of 2 all to the power of x. I'm then going to use my third law of indices, which says one power raised to another power, you multiply those powers together, so you get 7 to the power of 2x equals 7 to the power of 2 plus x. The bases are the same, and because there's only one term either side of the equal side, the only way the left hand side can be equal to the right hand side if the bases are the same is if the powers are the same. So I'm equating my powers there. and then I'm going to solve, and I'm going to get x is equal to 2. So that's it. Those 4 questions based around indices. But as I said, each one by itself is straightforward enough, but you'd be surprised at how few students get them all right. So if you did, well done.